Okay, so today we are going to revise the chapter light. Already it was done, but we are going to revise the chapter. So, any idea, Kritvik and Manasvi, what is light? What it is used for?
It's a visible spectrum.
Okay,
It contains a band of colors.
okay, it contains a band of color. What are those different seven
It is
colors?
A
Yeah,
Vibgyon.
Manasvi. Okay, Manasvi.
Ma'am, it is a source of light that humans can see.
Okay, the source through which the human can see. Fine, we both have given like some of the other points and all. But when I talk about the light, is a form of energy. Like different forms of energy are there, right? One of the form of energy is light. So light is what? Light is a form of energy. So different forms are there, like we say solar energy. So solar energy we have, light we have, the chemical energy we have. So out of those so many energy, light is also one form of energy. It is needed to see many things around us. So whatever we are able to see, it is because of the light only. So if we are in the dark room and we don't have any light, what happens? We will not be able to see any of the things around. So that is why the light is needed to see the things around us. Light enables us to see objects from which it comes or from where it is reflected. So with the help of the light, what happens? From wherever it comes from and wherever it reflects the light. So we will be able to see the things. We detect the light with our eyes. So for that, we will be using the sense organ called as the eyes. The next very important topic, that always light travels in a straight line, and this movement or this propagation of light in which the light travels in a straight line is known as what? What kind of motion? What kind of propagation? It is known as rectilinear propagation. So propagation of light in a straight line is called as the rectilinear propagation. So when a beam of light enters a dark room through a crack or tiny hole, it eliminates things that lie in its path. So you might have seen, like when you open a window or you have any hole in the room or somewhere, a kind of the open windows and all, from there the light will be entering always in a straight path. It does not get diverted. And if you keep something also in between, that time also it does not get diverted. It will be always in the straight form. The beam of light appears to travel in a straight line. The same is true about the beams of light from a torch, a lighthouse, the headlights of a vehicle. So you might have seen when your parents are, driving the car and all, you might have seen always the lights is like straight. It is not like when they are turning, the light also will be turning or zigzagging, zooming. All those things will not be happening, right? So always it is in the straight form. So thus light travels along a straight line. This is very, very important point, that always light travels in a straight line, and this is what we called as the rectilinear propagation. So you cannot see the flame through the bent straw because light travels in a straight line. So if you have noticed, like sometimes if we try to see the flame through the bent straw, you will not be able to see that, because what happened when the straw is bent, so the light will not be able to travel, because light travels always in the straight line. And if you are able to see, if you want to see, what you need to do, you have to use a straight straw. Then only you will be able to see the light. Then the next topic, reflection of light. So basically reflection means whatever the object we have, whatever surface it is coming, it gets reflected, it starts moving. So when light falls on a surface, a part of it hits the surface and returns like a ball. So like you might have seen when you play, maybe I can say ball. So when you hit the ball to the wall, what happened? It will strike out back at you. Same way, if the light also fall on any surface, they will also reflect back. That bounces back. This phenomenon in which light falling on the surface of the object is sent back the surface of the object is called as the reflection of light. So reflection of light is a phenomenon in which what happened? Whatever the light falls on the surface, it will be sent back by the surface of the object. So it comes and then it also goes back, it bounces back. And this is what the
Ma'am,
reflection of,
which
yeah.
means the bouncing back of light from the surface of an object, right?
Yes, correct, correct. So that is what
Okay.
the reflection is. So for example, now if I have a surface here, so this is what? This is a kind of surface. Now, for example, here I am standing, and what I did, I have just hit this surface with the any light, any form of light. Okay. For example, torch. If I am just putting the light of the torch here on this surface, what happened? Now this surface, they will be hitting back that same light in the straight form. Clear? So the light has been come from my side to the surface. Now the same surface has reflected that light back to the source. So that is what the reflection of light is. So light that is reflected depends on the nature of the surface. So what kind of nature of the surface is there? It depends on that. It can be regular surface, it can be the diffuse surface. So regular means when light strikes a smooth surface such that of a plane mirror, it gets reflected. Now, you have the plane mirror at home. So what happened? So whenever the light falls on it, they will be bouncing it back or they will get reflected back. Whereas in the diffuse, the light falling on the rough surface gets scattered in different direction. So if something, just 1 minute. Okay, so in the regular, what happened? Light will be striking and the same now on the surface, and then it will be bouncing back. Whereas in the diffuse reflection, whenever the light falls on the rough surface, it gets scattered. Like you might have seen paper. Okay, if I have a paper in my hand and if I am trying from one side, I'm trying to put the torchlight. So what happened? Are you able to see only one line? No, you will be able to see that different forms of the lines will be coming throughout the paper. So that is what the diffuse reflection of light. So light falling on the rough surface gets scattered in different direction, and this diffuses the reflected light. The next one, reflection by a plane mirror. So a plane mirror is a flat, smooth glass surface which is polished silver on its back faces, like normally whatever we use at home. Also, the plane mirror is that. So it is always plain, it is smooth, glass surface it is a polished silver on its back. So always at the back of the glass, what will be there? The silver polish will be there. This is very important point. So what kind of polish is there at the back of the mirror, plane mirror? The silver polish is there. This layer of aluminum or silver at its back is called as silvering. So present of this layer, which is present at the back of the plane mirror, either made up of the aluminum, either made up of the silver, that is called as silvering. Fine. So you have a plane mirror at the back of it. A layer is present which is like almost gray in color, and this layer is made up of either the silver or either the aluminium. And this process of this layering is called as the silvering. This layer is responsible for reflection. Now, again, a very important question: why this layer is important? So this layer is important for the reflection process. So if nothing is there at the back of the plane mirror, what happened? The light will not be able to, reflect back. So here you can see now a mirror is there, a plane mirror is there. One edge of this is noted by the O, and the second edge is denoted by the O dash. Now lights are coming, so ray of lights are coming on this mirror. You can see three different rays of light are coming on this. Now as soon as they are coming, what they are doing, they are bouncing back. So always keep in mind, suppose this we have the plane mirror, from wherever the light or the rays are coming, what do? They start bouncing back from there itself in a straight line. Fine. So the ray of light falling on the surface. So whatever the light which falls on the surface, they are called as the incident ray. So the ray of light falling on the surface is called as incident ray, and the ray of light reflected off the surface. So whatever the rays goes back, or I can say which bounce back, they are called as the reflected surface. So if they are coming on the surface, they are known as the incident, and if they are reflected back, if they are going back, then they are called as the reflected rays. So that is what the reflection by a plane mirror. So two types of rays are there, incident ray and the reflected ray. Incident rays are those rays which will be coming on the surface, and the reflected rays, they are those rays from which will be bounced back by the surface. Next one, plane mirror and images. So what kind of images are formed using the plane mirror? So when we talk about the plane mirror, when an object is held in front of a plane mirror, a copy of the object is visible in the mirror. So when an object is held in front of a plane mirror, a copy of the object is visible in the mirror. The copy of an object in the mirror is called as image. Like if I am also standing in front of the mirror, what happened? What I will be able to see? I will be able to see the copy of myself, right? So that one is called as the image. So the copy of an object in the mirror is called as image. So whatever picture of yours you are able to see in the mirror, on the mirror, that is called as the image. Now, what kind of image it is? An image can be real or virtue. So it is like, it can be in the original way, it can be the real form of, or it can be the virtue. Virtue means the virtual form of it. The virtual form of it. Now, if it is real image has certain characteristics of it. An image that can be formed on a screen is called as a real image. So real image are those images which can be formed on a screen. Second point, a real image is formed by rays of light coming from an object actually meet at a point after reflection from a mirror. So in this, what happened? They will be, whatever the rays are coming from the object, they will be meeting at a point after reflection. So whatever the rays are coming, what do? They will be meeting at a particular point. Like for example, if these rays are there, fine, the rays are coming, somehow they are meeting at this point and they form what? The real image here. They form what? They form a real image here. Fine. If the images, what do they do? Whatever the rays are coming from the object, they will be meeting at a point after reflection. So that is called as real image, which forms from the mirror. So we can see a real image even without a screen. So if we do not have a screen, we do not need any kind of screen. Without the screen also, we will be able to see it. If your eyes are in line with the rays coming from the image. The image formed on a cinema screen and the image formed in a pinhole camera are the example. So you have seen. So when you go to the cinema halls, whatever is coming in your screen, on the screen of that cinema hall or theater room, that is coming because of that real image which is formed on the camera there. So they have a kind of the system wherein they will be just playing that video, and those reflection you might have seen. Have you seen that the projector will be at the back and the image of that is reflected on the screen of the cinema? Have you noticed that?
Yes, ma'am.
Yes, ma'am.
So that is what the real image is. Whatever they are playing from the projector at the back, same thing is coming. Like in the school also, maybe in your school you have the smart class, right? There you might have seen projector will be somewhere else, maybe on the top of the screen or on top of the wall or something there. At the back of the class, it will be there. But whatever we write, maybe or we type on the keyboard, everything will be coming on the screen or maybe coming on the front. So it does not require any kind of the screen. We do not need any kind of surface in between for that. So that is what the real image are. Whereas in the virtual image, an image that cannot be formed on a screen, so which cannot be formed. So a virtual image is formed when light rays coming from an object appear to meet at a point after reflection from a mirror. So they will always form the virtual image. Virtual means something which is like we are just thinking of, but it is not originally present. Like trees. Shadows of trees, have you seen that? When you go in the car, you might have seen like trees form these shadows. So we feel like that is a reflection. Or when you sit in the car, your car is moving and you feel like the trees are also moving along with you, which is like virtual image of it. Originally it is not happening, but we are creating an image in our own mind that the trees are also moving with us. Buildings. So as we move in the car, what we feel? We feel that buildings are also coming like along with us. That are also moving. Then water, still water. So something is there in the still water. We feel like it is like something has been created there. So these are all the virtual images which are not present actually, which is not exactly happening. They are called as the virtual images. Then lateral inversion. I hope you know about this lateral inversion. You might have studied there in your class also.
Yeah.
Lateral inversion is basically when whatever there is there, whatever the sentence or whatever the name is there, it is written in the opposite way, right? Left and the right side of the image gets interchanged. So like that is why you might have seen in the ambulance. Ambulance is always written at the right to left or left to right. So originally it should be left to right, but they are changing it. So this effect is known as a lateral inversion. Why they are doing so? Sometimes what happen, the car which is coming, maybe the car which is present in the front, they have to see back. So when they see from their mirror, they will be able to read it properly that it is ambulance. Otherwise, if they are writing in a proper way, in the normal way, then what happened? They will not be able to identify that. So this effect where in a plane mirror, the left and the right side of the image gets interchanged. So left will be acting as a right and the right will be acting as a left for this. So this is called as a lateral inversion. And whatever the image will be formed, that is called as the laterally inverted image. Now there are few characteristics of the plane mirror. So what kind of the images will be formed by the plane mirror? The first one, the size of the image is equal to the size of the object. So for example, if size of the object is 1 centimeter, so how much the image they will be forming? The image will be of the same size. It will be of 1 centimeter only. It is not like the object is of 1 centimeter and the image what is forming is the 3 centimeter. No. So both have the same size, which is 1 centimeter. So that is why very, very important characteristic it is. The size of the image is equal to the size of the object. Second point, the image is upright or erect. So always whatever the image is formed, they are always upright. They are straight or the erect. The image is formed at the same distance behind the mirror as the object is kept in front of the mirror. So whatever the distance is there, like for example, the object is here, then the distance of the mirror is here. Maybe the distance between the mirror and the mirror is 2 centimeter. Fine. The distance between object and the mirror is 2 centimeter. And now whatever the mirror is going to reflect, the image will be formed where? After the 2 centimeter only. So that is why the image is formed at the same distance behind the mirror. So if the object and the mirror has a distance of 2 centimeter, so whatever the image is going to form, that will also be at the 2 centimeter only. The image formed by the plane mirror is virtual and cannot be obtained on the screen. So if we want that we should get the copy of it, we cannot get it. The image from a plane mirror is literally inverted. So as like left will be right, right will be left. So when we are standing in front of the mirror, so always you might have noticed like our right is that left and the left is our right. When you click the photographs also, it happens the same thing. Now uses of the plane mirror, where we all can use a mirror for making the periscope, kaleidoscope, looking glasses, box type solar cookers. So different uses are there of the plane mirror. Now coming to the very, very important topic are the laws of reflection. So when the rays are bouncing back, they gives us the few laws. Two laws are there. So reflection of light on a surface follows two definite laws, and these are called as the laws of reflection. The first law states that the angle of incidence is always equal to the angle of reflection. Very, very important. So whatever the rays are coming on the screen are called as incident ray, right? So the incident ray are always equal to what? The reflected ray. So they are always equal to the reflected ray. Now, if the angle of incidence is 30 degree, so what will be the angle of reflection? If the angle of
30
incidence
degree.
is correct, so it will be 30 degree. If the angle of incidence is 60 degree, so what will be the angle of reflection?
60 degree.
60 degree. So always keep in mind the first law of reflection states that the angle of incidence is always equal to the angle of reflection. If angle of, and it is written like this, angle and then I, small I, which is angle of incidence, and then angle symbol, then small r, which is angle of reflection. So angle of incidence is equal to angle of reflection. So if sometimes any numerical comes, if in the question they have given that the angle of incidence is 25 degree, so find out the angle of reflection. So there is nothing to do. What you should do, you should just write the statement for the first law of reflection, and you should write them directly. It is 25 degree. So first mention the first law, what it is, and then write the answer for it. Now coming to the second law states that the incident ray and the normal at the point of incident all lie in the same plane. So this is what the plane is, right? So always whatever the incident rays are coming, what they are, or point of incidence, point of incidence is like where the place they are meeting. Fine. The center point of their meet, the point from where the light is going to reflect, that is what the point of incidence. So the incident ray and the normal at point of incident, they all are in the same plane. So point of incidence is also there, angle of incidence also there, and from the same point, what happens? The angle of reflection also will be there. And between this incident ray and the reflected ray, the straight angle is what? The normal is called as the normal. So like here we have what? O and O dash. Angle of incidence is coming here. Angle of reflection will be from here. So where the normal will be? The normal will be with the in the center of this two rays, in between the incident ray and in between the reflected rays. So there in the center we'll have the normal. So those are the two laws of it. Now the next type of the mirror is the spherical mirror. So unlike plane mirror, that are flat spherical mirrors have curved surface. So these kind of mirrors, what they have the curve kind of surface. They are of two kinds, concave and the convex. So starting with the concave mirror, a concave mirror is a spherical mirror whose reflecting surface is on the inner side. It is also known as converging. Converging is basically so here what is happening here, the converging will be happening. In the case of the converging, all the rays whatever is coming, they will be meeting at a particular point like this. So this is what the convergent. So it is known as the converging mirror. As a parallel beam of light after reflection from a concave mirror, they will be converging at a point. Converging means they will be meeting at a point. So whatever the rays are coming, all the rays, they have to meet at a point. And if they meet at a certain point, then it is called as a converging mirror. So this is the best quality of what? The concave mirror. So always whenever we are using the concave mirror, the reflection or the reflected rays, they will be meeting at a certain point. And always the concave mirror, what they will be doing, they will be forming the real images. So image formed by the concave mirror can be the real image and can be captured on a screen. The image can also be inverted and they can also form the virtual images. Now where we all can see the concave mirror? In the shaving mirror. So you might have seen your father might be using the shaving mirror. Shaving mirror is basically a little thick kind of mirror, and mostly in the hotels also you'll be finding out this. They are using as a reflector in the headlights of the vehicle. So in the headlights also these concave mirrors are used. In the searchlight also the concave mirrors are used. Then for the telescope also they are used. Then solar cookers also they are being used. Whereas convex mirror, they are also a spherical mirror whose reflecting surface are present on the outer side. So outside, what do they have? They have the reflecting surface, and they are known as diverging mirror. Now diverging means here that from the point what is happening, all the rays are, they are diverging, they are segregating out, they are separating. So in the case of the concave, what was happening, all the rays were meeting at a certain point, that is why they are called as converging. Whereas in the convex one, whatever the point is there, from there all the rays will be diverging, they will be moving out in the separate form. So it is also known as diverging mirror, as a parallel beam of light after reflection forms a convex mirror diverges. They will be diverging in the separate way. And convex mirror, always they will be what? They will be forming the virtual images. Always the virtual images will be formed. So it is not possible to project the image formed by the convex mirror on a sheet of paper. A convex mirror does not form a real image, it only forms the virtual image. So only the imaginary things will be formed by the convex mirror. Where we can use it, they're used in buses to help the driver to see the whole bus. They are also used as a rear view mirror of vehicle. Then they are used in the field view mirror as a supermarket, as they have cover wide range of vision. So the place where we have to see big things and all, there we can see this type of the convex mirror. Now coming to the difference between the plane mirror, concave mirror and convex mirror. Plane mirror always will be erect. It is virtual and of same size as the object. Concave mirror, they can form real as well as an inverted image. Convex mirror will always form the erect and virtual image, and they will be smaller than the size of the object. So that is why you might have seen, like if you are sitting in the car and from your the mirror of the car, when you see any back car, what you feel like? You feel like the cars which are coming at behind, they are always small. So the smaller in size in the object. Second one, the image is at the same distance behind the mirror as the object is in front of it. Whereas in the case of the concave, when the object is placed very close to the mirror, the image formed is virtual, erect, and magnified. So whatever the object we are placing to the mirror, they will be forming the virtual and the erect kind of images. Yeah.
Ma'am, what is the meaning of erect?
Erect means straight,
Oh, okay, ma'am.
kind of straight. Now, this was about the plane mirror. So, in the plane mirror, two categories were the concave mirror and the convex mirror. Now, same way, we have the lenses. Like you might have heard, like you in the spectacles, we have the lens, right? So, we have the different kind of the lens called as the concave lens and the convex lens. Fine. A lens is a transparent material such as a glass with two surfaces, out of which at least one is a spherical surface. Now, what happens in a case of a plane mirror? What was there at the back?
Silvering.
Right? Silvering of silver or the aluminum. But here, in the case of the lenses, they do not have that. So, nothing will be there at the back of them. Both the sides will be transparent. Fine. So two types of lenses are there, concave and convex. Concave, they are the thinner at the middle. You can see these are the what? They are the kind of the concave lens. So in the center, they are what? They are thinner. Whereas on the edges, they are the thicker. And they are called as diverging lens. In the concave mirror, what they were known as? Concave mirror was also known as the
Converging lens.
yeah, converging mirror. Why? Because they were meeting at a certain point. But here, in the concave lens, they are called as diverging. Because as soon as the rays comes to them, what do? They start splitting. So here, if any ray is coming, what do? They diverge, they get separate. Again, one ray is coming, they get separate. So that is why the concave lens are called as diverging. So Concave mirror, they are converging, whereas concave lens, they are diverging lenses. Okay. So both are opposite. Concave mirror, they are the converging. Concave lens, they are the diverging lens, since they diverge a parallel beam of light passing through them. Whereas now convex lens, from the center, they will be thicker. They are thicker from the center, and from the edges, they are thinner. And they are called as converging lens. So in the case of the convex mirror, what they were? They were the diverging mirror. But here, in the case of the convex lenses, they are the converging lenses, because they converge a given parallel beam of light passing through them. It means after passing through them, what do? They meet at a certain point. So you can see here, they are meeting at a certain point. So both are opposite. When I talk about concave mirror, they are the converging one. Then concave lens, they are what? They are the diverging. Then convex mirror, they are basically the diverging. But in the case of the lens, what do? They act as a converging. So that is how they work. Concave mirror converging, concave lens diverging. Then convex lens, convex mirror diverging, convex lens converging. So that is the two types of the lenses. So a lens has two spherical surfaces, hence why they have the two center of curvature, one on each side of the lens. Now, what kind of images will be formed by the concave? Concave lens cannot produce a real image. So as this line we were learning where? We were learning in the convex mirror, that in the convex mirror, the real image cannot be formed. So whatever in the case of the mirror we have studied, whatever the concave mirror we have studied, that will be coming under the convex lens, and whatever in the convex mirror, whatever we have studied, that will be coming under the concave lens. So in the case of concave lens, cannot produce a real image, as the light passing through them cannot be converged. They always form the virtual. Diminished means small. So always a virtual, a small, and the erect image they will be forming. A concave lens diverges light. This means it bends light outwards, and thereby they are called as the diverging lens. Whereas in the convex, what happened? They will be forming the image which is always placed far off, and they will be real, inverted, and much smaller than the size. They can also form the virtual, erect, and the enlarged image also if we are placing the object at the close side. Now, uses of the concave lens, they are used for making the spectacles, they are used for making the kinds of telescope, for making the peepholes. Have you seen in the hotel room, there will be peepholes, and when you peep into that holes, what you will be able to see? What kind of image you will be able to see outside? The small image or the big image?
A bit diminished.
Yeah, correct. Fine. So diminished image will be able to see big, it will be. So a clear image, but a small version of it you will be able to see through the hole of that peep. So there where the concave lenses will be used, whereas the convex lenses are used in the magnifying glasses for making spectacles. And spectacles basically for both the things we are using, concave and convex, depending on the requirement, depending on the eyes actually. Then cameras have the convex lens, microscope have the convex lens, telescope have the convex lens into it. The next topic, dispersion of light. So dispersion is basically when the light is coming and hitting the prism, then what do? They start reflecting the light in the different, or they start scattering the light into the different forms. So light that is colorless is called as white light. White light is a mixture of lights of 7 color, which are the Vibgyor: violet, indigo, blue, green, yellow, orange, and red. When these color combines, they look white. So when all these 7 colors they join together, they form the white light. It was first discovered by the Sir Isaac Newton, where he used a transparent glass prism to split the white light. So glass prism look like this, okay? So what he did, he just hit the light here on this glass prism, and what he noticed that as soon as he hit the light on this glass prism, it start, scattering into the 7 different colors of it, like this. So Sir Isaac Newton, where he used a transparent glass prism to split the white light from the sun into its constituent 7 colors. Phenomenon of splitting of white light into 7 component colors is known as the spectrum, or it is also called as the dispersion of light. So when the white light gets split into the different 7 colors, that is called as the dispersion of light. And that is how the rainbows are also formed. So rainbow is an arch of 7 colors in the sky. The different colors in the rainbow are formed due to different dispersion of sunlight, and it passes through the small water droplets in the air after rain. The different colors thus formed appear in the form of a large curve in the sky called as a rainbow. So what happens? The sunlight, what they will be doing, they will be doing the dispersion through the water droplets. So in the clouds, what are there? The water droplets are there. Those they will be dispersing in the air, and because of which the different colors will be formed. Then Newton's disk. If white color is made up of light of 7 colors, then the 7 rainbow colors can be recombined together to form the white light with the help of the Newton disk. So Newton disk is a kind of disk. You might have seen like CDs, right? CD, DVD also. You can see the different colors on it. But as you rotate them, you will be able to see only the white color of it. So the way light mixes was first explained by the famous English physicist known as Isaac Newton. He showed that on rotating a rainbow colored disk, it appears white. So when we rotate that disk, we will not be able to see the 7 colors, but what we will be able to see, we will be able to see only the white color. So that is how he explained the concept of this dispersion of light. So any doubt you have, Kritvik, Manasvi and Varshit? Manasvi and Varshit, kindly turn on your video. Any doubt, children?
No, no.
No.
So this is like very, very important chapter. You're going to have in very, very detailed form in the grade 10. A very, very, very detailed form you're going to have in the grade 10. And very important chapter for the physics for the grade 10. So make sure that you read it very well. You should understand it very well. So what I have done is 2 types of notes I have uploaded on the WISE app. So kindly go to the WISE app. Under resources, there will be a folder by the name class-wise notes. In there, you will be finding, let me tell you, wait. There by the name, I think, light notes. Don't go for the file light foundation. Light foundation will be doing the next week. Solving of the question will be doing the next week. Go for the second and the third notes, light and light notes. Find these notes, you open and learn, read them. Okay. These notes, both of the notes, open and read them. And if in case of any doubt, you ask me. And keep these notes safely for your higher classes.
Yes.